Hey, what's up, everybody? And welcome back to day 2 of Build 2013. And if you guys missed any sessions from yesterday, don't worry about it. Anything from Soma or Googs or any of our other Channel 9 live sessions, they're all going to be on channel9.msdn.com under the events page, so go check them out. They should be up there already. And if they're not, that's my fault. I'll go do it right now. But they will be up there. And don't worry, because Channel 9 is never here to disappoint. And today we have two hosts. We have Charles Torrey and Scott Hanselman. And I'm going to let Charles Torrey take it away right now, baby. Let's go. Let's go.
Right on, man. Welcome back to Build 2013. Thank you, G Money. Very, very happy to have Anders Hausberg with us.
Charles, always good to see you.
Great to see you too, man. So we're going to jump right into this. As you know, Anders and company have been working on TypeScript. It's at 0.9 now.
That's right.
So now's the chance to ask any and all questions related to TypeScript or whatever you want. We'll see what Anders wants to talk about. So right off the bat, you had a great session yesterday. Talk a little bit about who's using TypeScript in the real world.
Sure. Yeah, we had about 1,000 people at our session for TypeScript. We launched TypeScript 0.9 just about a week ago, and that was sort of like one in a step of releases leading towards 1.0, which hopefully will be later this year. Okay. I'd say at this point, the language is largely complete, and now we're working on scalability, perf, Visual Studio integration, just sort of hardening the whole system towards the final release. Okay. Who's using it? Pretty much anyone who wants to write a large application scale JavaScript app. The thing about JavaScript is it was never designed to be, a language for 100,000 line apps. Sure. It was maybe for 100 line apps. Yet we're writing these huge apps, and the language is straining. It needs, or people feel like they need classes, modules, interfaces, and static types with which you can power intelligent tooling. And that's really what TypeScript brings, but then it compiles it all the way into plain old JavaScript. So we have actually, we're looking at our downloads, upwards of half of our downloads are coming from non-Microsoft platforms. So it's being used a lot out there in the open source community, on the standards web. People are using it on MacBooks or Linux machines, on Android. I mean, they're like, you name it. We have users all over the place.
Awesome.
Yeah.
So we have a first question, very good one. We've talked about this before in our last interview. Yeah. But of course, async await is awesome.
Yes.
And it's in C#.
Yes.
It's probably, hopefully, going to come to C++. Any plans for async await in TypeScript?
Yes, we've thought about it. We've thought about it a lot. In fact, someone already created a fork of TypeScript where they implemented async.
Nice.
We're not gonna take that pull request this time around. Here's the problem. We sort of have two conflicting forces here. There's the mantra in TypeScript that we have that we want to generate beautiful JavaScript code, and whenever you look at that code, you're going to go, oh yeah, that's my code right there. It's just, we've inserted the patterns for classes and modules and whatever. The problem with async is to try to do async without any kind of generator, iterator, or asynchronous support in the VM, immediately your code turns into spaghetti with all sorts of helper stuff, and we have to make a state machine and wrap switch statements around everything, and it's essentially unrecognizable and hard to debug. Okay. Now, what's happening in ECMAScript is that ECMAScript 6 is very likely to include support for generators or iterators, which are very similar to iterators in C#. The ability to yield multiple results out of a function, okay. Right? A restartable function, if you will. And once that support is there, it's very easy for us to wrap async around that, with that being the engine, and basically transform your async function into a generator with the appropriate little bit of support, and then TypeScript will take care of making the typing all work out. Do you know what I'm saying? Because like in JavaScript, the generators can just yield anything you want right at any time. So that's what we're thinking, that if that happens in ES6, then we have a perfect vehicle upon which we can add async
Now, what if it doesn't happen in ES6?
Well, I mean, we could still take the spaghetti code, you know, but it's something that we were not comfortable with doing in 1.0, and quite honestly, we had to ship too, right? I mean, so it's not a simple feature.
Of course.
But we hear it, we understand the need. I want to do it. Yeah.
Great. So Ron Trujillo wants to know. He's a dynamic CRM guy for a medium-sized company. What can I use TypeScript for?
Well, I would sort of more say, I mean, what do you have problems today with large JavaScript code bases? And if you do, then TypeScript is useful.
Okay.
If you don't have large JavaScript code bases, you know, I wouldn't necessarily just adopt TypeScript just because, you know, I mean, it's a tool for a particular purpose. Okay. Application scale JavaScript.
Interesting.
Yeah.
That's a very, very important point.
Sure.
But it's a really beautiful syntax versus JavaScript itself, but that's my personal opinion.
Well, I mean, it's interesting because it is a superset of JavaScript. Okay. So, you know, I mean, in a sense, I think it adds, the way I think about it is that it strengthens JavaScript with those features that are missing for large-scale application development.
Okay.
And that boils down to things like classes, modules, interfaces, and then static typing or optional static typing, if you will. Because static typing is really what makes it possible for us to build intelligent IDEs. You know, like things like code refactoring, go to definition, find all references, deeper understanding of what your code does. Mm-hmm. We need static types for that. You know.
Sure.
But then we can just compile all the types away, and you have JavaScript that'll run anywhere, right?
So that's interesting. I mean, I wish we had like an hour with you because it'd be fun to talk about when types disappear. I mean, are types really only useful on the front end, on the design time experience? I mean, isn't it nice to have typedness all the way through to execution?
Sure, it is. I mean, and you see it used a lot in .NET, right? Sure. Reflection is basically types at runtime, right? And the ability to reflect or introspect on your app as it is running. Now, JavaScript does have some basic reflection capabilities. I mean, you can enumerate the properties of an object, you can ask it a function for its source code and whatever, but not all of the type information transfers over. But in a sense, that's also good because, you know, people do often complain with .NET about the overhead of all this metadata that isn't being used for anything. Do you know what I'm saying?
Yeah.
It's like, why am I simply so big? Why do I have all this private metadata that I never reflect on? You know, I want to get rid of that. And in a sense, the balance is different, you know, with TypeScript, JavaScript. Less of that type information makes it into the final runnable code, if you will. Mm-hmm. But yes, it's still useful. And there are certainly things like dynamic attributes and whatever that are useful in .NET, and there are some ideas for how we could do that, you know, but I'm not ready to go there right now. Yeah.
All right, so keep asking questions. If you're watching this, you see the little text boxes underneath the video. You can just simply ask your questions there. No need to tweet. Alex would like to know, does arrays are covariant in TypeScript? So are arrays covariant in TypeScript?
They are.
Why?
Why? Because otherwise they wouldn't be useful. No, it's basically covariance. It's always a little bit hard to explain, but you have to think of an object hierarchy. Imagine you have a root object and then say you have a type called string that derives from object, right?
Okay.
Now imagine that covariance then means, do you have the same inheritance relations or type relationships across operators like generic types, for example? So if string inherits from object, does array of string inherit from array of object? Mm. If we say it does, then in order to strictly be type safe, you can't really be covariant, because now imagine that I make a string array, okay? And I store it in a variable of type object array, and now I start writing elements into the object array, right? Well, I could write anything into an object array, including a lawnmower object, right?
Sure.
And now all of a sudden I would have lawnmowers in my string array, which obviously is not type safe, right?
Absolutely.
So you can be covariant in a sense safely, because covariance forbids you from reading or writing. But Well, no, I guess, no, the question was, are we covariant or are we contravariant? We are actually both in TypeScript. Right?
So the question was covariance.
Oh, it was covariance, yeah, okay. Now it ends up not being safe technically to store operations, to do store operations into arrays that way, right? And that's something that we don't check. Now in .NET, there's a runtime check on every store into an array that actually dynamically checks that you are putting the right thing into the array.
Okay.
We don't have those checks in JavaScript, and therefore, technically, it is a hole in the type system. But if we didn't have the hole in the types, the only way we could plug the hole is by saying you can't write to arrays. Well, okay, but what point is there in that, right?
Sure.
I mean, so pick your poison.
Right on.
You know, yeah.
So now JavaScript does, and including Chakra, we support typed arrays, right?
Yes, but
that's a different concept.
That's a different thing. Typed arrays in JavaScript are about natively representing memory as an array. Okay. You could basically create you can take a block of native memory and wrap a typed array object around it, and then access it from JavaScript. And it's great for getting access to native buffers, video memory, that sort of thing from JavaScript programs.
Right on.
Yeah.
Very important to ASM.js, for example.
Actually, it's part of the story for ASM.js.
Right on.
Yeah.
All right, let's get some more questions. So Thien would like to know, how will TypeScript evolve with the standard organizations?
Sure. Well, so we've worked hard in the TypeScript design team to track as close as we possibly can to ECMAScript 6, which is in process and likely to be probably ratified next year if things go according to schedule. Lots of features that are in TypeScript are very inspired by ECMAScript 6. So our class syntax is the same as ECMAScript 6. Okay. Now, mind you, we, on top of that, support type annotations, which are not in ECMAScript, but the base syntax is the same. Our arrow function support is the same. We have support for, methods and object literals, same way that ECMAScript 6 does it. Our modules, we've tried to track as closely as we can, although they're not done with modules in ECMAScript 6, but we will align, once a final. So we're very serious about, tracking as best we can the standards, and then the value that we feel we bring to the proposition, even after ECMAScript 6 comes out, is the optional static typing, because that will never be in ECMAScript. I mean, I think the committee has made that much clear. ECMAScript 4 was about adding static types, and that sort of all blew up and everyone walked away, and then it did ECMAScript 5, which was scaled back, and I think the committee is pretty clear that they're going to stay purely dynamic.
Okay.
And so there is still that opportunity for TypeScript to add static typing on top of JavaScript.
Absolutely.
Yeah.
I mean, and that sort of, one of the powers of JavaScript is that it's dynamic, right? I mean, not to get into the dynamic versus static thing,
no, absolutely. I mean, so types are interesting in that they bring a lot of safeties and a lot of a deeper reasoning ability about your code, but they also sometimes can get in your way, right? I mean, it's like, hey, I don't have time to think about the types right now. I know what I'm doing. It's like I'm writing 10 lines of code. Why should I think about it?
Exactly.
Right? And also, there are things you can do dynamic. Often, if you're talking to something that doesn't have any types, like I'm calling this REST API or this web service, and it doesn't have any types. I don't have a schema for it. It's no one. I just know that it has the following properties, right? I mean, fine. Why do you force me to write some encapsulation and put it into a strongly typed class or whatever? There's no reason to do that. Now, this is the beauty actually of optional static typing. The way it's done in TypeScript is that you don't have to. If you don't want to do types, just say this variable's of type any, or don't give it a type at all, and then it's just JavaScript. And you can do whatever you want. But, if you're going to use this same object hundreds or thousands of times, maybe it's convenient to have statement completion and a little bit of checking. So declare an interface and just say it's of that type now. And now we will enforce it for you.
Right on.
Yeah.
So in some sense, TypeScript enables one to catch their errors as they type them.
Well, or not make the errors to begin with, right?
There you go.
I mean, yeah. But, and it's not just that, it also actually allows us to track what type a particular entity is associated with, so that if in a huge code base at some point later you want to refactor and change the name of a property, right? Then the type system knows for you which of these properties called foo out here in these 100,000 lines, and there are many from different objects, right? And now I want to rename, but only in this object. Well, if you haven't said which foo belongs to what type, there's nothing a system can do to help you, right? And that's why these huge JavaScript code bases gradually become read-only code. You dare not touch it, right? Because it's going to blow up. How do I know? There's like 1,000 foos in here, and I could accidentally get the wrong one when I rename it, right? Because I gotta just like look at the code and make a decision right now.
Absolutely.
Yeah.
All right. So Z wants to know: will I ever have a nice debug experience, i.e., put a breakpoint in my TypeScript code and inspect?
Sure. This is work in progress. I mean, so you can, if you're running from within Visual Studio, or you're using Visual Studio as your debugger, you can already do that. Now, you're going to be debugging. I mean, you can single step through your TypeScript code, and you can use the expression eval, and watch windows, and whatever, and see all your JavaScript variables, which have the same names.
Okay.
If you're using the F12 tools, we support generating source maps. Unfortunately, IE doesn't yet support consuming source maps. Some of the other browsers out there, like Chrome, Firefox, do support it.
Okay.
And we'll eventually get that support in IE too.
Okay.
So it's work in progress that we're, yeah.
Right on.
Yeah.
Will TypeScript support generic lists? Does TypeScript support generic lists?
Well, it does in a sense. So with TypeScript 0.9, we have added generics to the type system, and we now use generics in our type descriptions of the JavaScript runtime library and the DOM. And one type in particular in there is the built-in JavaScript array type, which is now defined as a generic interface called array of T, which is very similar to a list of T. And you can add elements to it, and it has operators like map and filter and reduce and so forth. So yes, it does, but we didn't actually have to do anything other than just write down the type declaration and make it generic. Right?
Awesome.
Yeah.
Son of Sam, all right, would like to know TypeScript's integration with MVC and web forms inside a script tag. It's more of, I guess it's a question.
Yeah. So right now we do not support compiling TypeScript and script tags, although there are actually some add-ins that do it on the browser side, and there may be some on the server side too, but I'm not 100% sure.
Okay.
But it's all of these things are things that we would like to do,
Sure.
But right now our focus is on getting the language done,
So the next question from Atif, I'm assuming that's how you pronounce your name. I've seen this question asked a lot. I mean, link, right? One of the great things you guys worked on in C# is adding link, and that requires iterators, right?
It doesn't necessarily require iterate. I mean, so link is a set of operators over sequences, if you will, or IEnumerable of T.
Okay.
Now, JavaScript doesn't have an IEnumerable abstraction per se built into it. It has arrays, and array has methods that are very link-like. And now that we have generics and Lambda functions, you can actually write link-like code just with normal JavaScript arrays, or TypeScript, if you will.
Cool.
Now, there are also libraries out there like JSLink, and someone has already written the declarations for that. I think they're up on Definitely Typed, which is this open source website that collects declaration files for TypeScript. So there are many ways you can come at the problem.
Okay.
Certainly, the type system has the strength now to do link-like operations. I would say modulo, in C# we also have comprehensions, the from, where, select, whatever, that kind of look like SQL queries. We don't have that in JavaScript, and we likely won't do that, but honestly, that's really more like which kind of sugar do you like, brown or white, I mean, it's so yeah.
Right on,
yeah.
right on. So Raheel wants to know, will TypeScript include code generators to create types from .NET classes?
I know there are some already. I've seen a couple of either on CodePlex or GitHub. There are already some tools out there that use reflection on .NET types and then generate TypeScript interfaces based on that. So there's something out there already.
Awesome. And I think on that topic, before we get to the next excellent questions, you guys went out with TypeScript open source right out of the gate.
Right.
And what you saw from that is clearly excitement in the developer community and a sense of awesome, we're going to actually inject some of our own ideas into here, we're going to fork things, we're going to get it running on blah, blah, blah. I mean, that should be the thing we always do.
Well,
or why wouldn't we always do that?
Sure. I mean, it certainly has been a learning experience for me, to see how the open source community works and how, in a sense, people are willing to do enormous amounts of work for zero compensation, just like to get creds in the community or because it helps them and then others will help them with their problems, and it's a different way of approaching it. And I'm really liking it a lot. I mean, I think it's a lot of fun. I think it's fun to contribute there and see the excitement. I mean, to me, it was just amazing to see the community, run with TypeScript, adopt it, and then out of nowhere comes this website called Definitely Type that collects all the declaration files, and now there's more. I think there's over 200.
Wow!
And of the 20 top JavaScript frameworks, 90% of them are covered with TypeScript declaration files, and moving to generics now with TypeScript 0.9. So it's a lot of fun, and for sure it's something we'll do more of.
Cool.
As we go forward in our other development ecosystems.
Excellent.
Yeah.
So Sergio would like to know, can TypeScript be used in conjunction with Backbone and Underscore?
Yes, absolutely. In fact, both of those have declaration files on Definitely Type. I actually used, interestingly, underscore.js as my litmus test for writing down the generic type declarations because there's an enormous amount of genericity in all of the methods or all of the functions declared in underscore, because they're sort of linked like operators on arrays and on functions and objects, convenience functions, but they all are generic in nature. They apply a certain operation over a list of some type, and you want to be able to have that flow through the calls to the underscore methods, and as you dot them together, you want the types to flow. And
nice.
And so it was fun to write down the generic version of that. Now I'll have to find a way to get it back to the community.
Right on.
Yeah,
Anders shipping back to the community.
But so yes, and Backbone also. Yep.
Excellent. So Alex would like to know, are you planning on creating VS templates for Win8 store apps that use TypeScript?
Yes.
Perfect.
That's part of the work that we need to do getting to 1.0. Yep.
That would make so much sense.
Yep, absolutely.
By the way,
we do have a sample, by the way, already
All right.
of a Win8 app that uses TypeScript. And if you download the TypeScript samples, or you can just play with them on our website, you'll see it's the one called Encyclopedia. But we don't have all of the templates in place in Visual Studio yet, so that's just on our to-do list.
Excellent. Now, we released 8.1 yesterday. I'm assuming there's an app in there that maybe they're using. So inside of Microsoft, folks are using TypeScript.
There are several. Yeah, I mean we're seeing a lot of uptake in-house and externally. One of the apps we showcased in my talk yesterday is the new Xbox Music app.
Excellent.
Which is Xbox Music it's actually a remarkably large app because they target not just Windows 8 but also Xbox One, and and they're going to be targeting the whole Windows ecosystem with this app, right?
Okay.
It's about 500,000 lines of JavaScript code. I believe that they had a pilot project to test out TypeScript and loved it so much that they decided to stick with it. And I think now they have 30,000 lines of TypeScript code, and they're using it for all of their new features now.
Excellent.
So the new UI, whatever that Dan was showing yesterday in my app is all written in TypeScript, and they're big advocates.
Awesome.
We saw today in the keynote, the Adobe display digital publishing system, their viewer app is written in TypeScript.
Awesome.
We're seeing Bing make lots of use of TypeScript. Social from Fuse Labs, is using TypeScript. So it's spreading quite rapidly.
Excellent. That's rock and roll. Salman wants to know, what's the difference between TypeScript and other type JavaScript languages? So it's the CoffeeScript versus TypeScript kind of thing?
Well, so CoffeeScript isn't typed.
It's not
And so
typed.
that's one of the big differences between TypeScript and CoffeeScript is static typing.
Okay.
CoffeeScript doesn't have any. I'd say the other big difference is that we're a superset of JavaScript. CoffeeScript is a different language.
Okay.
So you can't just take your JavaScript files and rename them to CoffeeScript. I mean, all you'd get is errors at that point, right?
Sure.
But with TypeScript, you can actually, and then just add some type annotations. So the barrier to entry is much more friction-free, I would say. And then, as I mentioned earlier, you know, really, if you deeply think about it, the thing that truly enables application scale tooling is static typing. And that's not in CoffeeScript. There are others out there like Dart, for example, which is, but Dart's sort of primary pivot point, if you will, is creating an alternative ecosystem to JavaScript. Sure. And they also support cross-compiling to JavaScript, but now they have to pay the price of emulating their ecosystem on JavaScript.
Sure.
You know, and that adds a bunch of cost.
Totally.
So I think TypeScript is the only one out there that's a superset of JavaScript that provides static types.
Excellent, man. Carl would like to know, is there any advantage in using TypeScript to stop security issues?
Not directly, I wouldn't say, but what are security issues, right? Security issues, in a sense, you could argue, are exploits of code where you maybe didn't reason correctly about the types in the code and whatever. But it's not I mean, no, I wouldn't say TypeScript directly saves you there, no.
Makes sense. So how soon will TypeScript be available in the script in the online Azure portal?
In the script in the online Azure portal. I thought it already was available as a language up there. I know that in the Azure portal viewers, you can view TypeScript files. Now, in terms of using, maybe it's as a language in the Azure web, the mobile web services, maybe use it as a language for authoring. I'm not sure if it's there yet. It's something that we're going to look into for sure. I know that the editor that is used in Azure, the little edit pane that you use in the browser, if you're editing code in the browser, is the same that we use in the TypeScript playground, and the team that builds that actually uses TypeScript. So it's already in there. Now, whether we've exposed it all the way, I'm not sure. So maybe we could get a little more specifics on how, but yeah.
Excellent. And yeah, we save all the questions, and just so you can tweet it to us, and we'll see if we can get a full answer. Kevin wants to know, is it possible to generate TypeScript from JavaScript?
Yeah, it's like well, if it was, then we wouldn't need TypeScript, right? I mean, that's the flippant answer. Now, it's interesting. I mean, JavaScript is TypeScript, but it may not be TypeScript that compiles without errors. If you just take a JavaScript file, we will for sure parse it because the syntax and at a parse lex level is the same.
Okay.
But at the semantic analysis level, when we analyze the types, it's sort of like a lint tool, right? It might point out a bunch of things that you know, potentially are errors. Some teams, actually, I saw recently a team had built, in order to more rapidly adopt TypeScript, it's an in-house team, they had built a tool that would take a JavaScript file, just compile it with the TypeScript compiler, gobble up all the errors, and then it would inject dummy variable declarations to silence the errors. And then you could just sort of, and then you could at least get a clean compile, and then you could go in and then like look at all of these variables that were declared, and then you could give them the correct types.
Got it.
Because, for example, we will complain if you try to access a global variable and we don't see a declaration for it anywhere, right? And so it is possible. So we're looking at doing some of these things, but they'll never be perfect, right? Because, I mean, we can't infer automatically what the types are. If we could, then we wouldn't need TypeScript in the first place, right?
Exactly.
So at some point you got to get in, but we could perhaps make the transition in even lower barrier than it is today, and it's something we're looking at. Yeah.
Great. So Michael wants to know, do you recommend using TypeScript for other platforms that are using HTML plus JavaScript, like Tizen, for example?
I think TypeScript is a perfect vehicle for any place where you have JavaScript and where your JavaScript is likely to be large, or where you are targeting some large framework. Like, for example, you're writing like little like event handlers or, you know, triggers that run when data is inserted, and there's like a big validation framework that you can call, and you don't remember all of the methods that are available in there. Well, if you write declaration files for it and you use TypeScript as the editing experience, then you can actually get statement completion in those. And the cool thing about our compiler and our language services is that they're all written in TypeScript. They're all open source. They all compile to JavaScript, and that JavaScript can run anywhere.
Yep.
And so we're seeing people incorporate our language services in their development tools already, like Cloud9 and WebStorm, and I know there's a plugin for Sublime Text. And these are all like tools that we had no hand in creating or whatever, and they have plugins now for TypeScript, not just colorization, but also statement completion and whatever. So yeah, it's pretty cool.
And that's another side effect of being open source.
Absolutely. It's like if the community starts to like you, it can really go fast.
It's a beautiful, beautiful thing, man. Yeah. Let's go to Quick C. Can the tooling for Windows Runtime JS promises be used in TypeScript?
Yes. In fact, with generics, it now can be used, and the types. I wish I'd had time to show that in my demo. Yes, there were just too many things to show.
Sure.
But in the Encyclopedia sample app that we have in our TypeScript samples, it uses promises heavily because WinRT and WinJS uses promises heavily.
Sure.
And we now can correctly flow the types from a promise returning asynchronous function through the .then method where you give the callback, and then the parameter of the callback automatically gets the type of the promise.
Awesome.
Flowed by generics, right? So it's beautiful, man. It's beautiful.
Great,
yeah.
great.
Yeah.
So can we use enterprise level patterns in TypeScript? What are enterprise level patterns?
I'm not exactly sure.
All right, let's move on. We're running out of time, so
okay.
we'll go to, but thanks for the question, Juan. What is the story of TypeScript integration in SharePoint full trust solutions?
That I don't know. Okay. I know that we have integration in the SharePoint tool set, the Napa tools for Office 365, but I'm not sure about full trust, what that is.
Okay, so when will I start to see TypeScript samples in MSDN, etc.? Dave asks.
Well, that's a good question. I mean, I suppose we could consider that. I mean, I certainly, all the JavaScript samples are TypeScript, but you won't have the type annotations. But still, I mean, they're basically 90% TypeScript to begin with, right?
Sure.
So yeah.
Awesome. And one other thing, so WinJS itself could be TypeScript.
Oh, it is TypeScript.
Right.
I mean,
that's a lot of. I mean, that was a huge file.
Well, it's a big file. Well, it itself could be written in TypeScript.
That's what I mean.
We've actually had some of those conversations.
Okay.
It's more a matter of timing than anything else. But what we do have is we do have declaration files. We have a winjs.d.ts that provides you all the TypeScript declarations, and they are now in generic form. Awesome. We have the same for WinRT. In fact, for WinRT, we can automatically generate these files because we can suck up the WinRT metadata and then generate TypeScript declaration files automatically,
awesome.
which we do. So all of that is already there in our current distribution. Yeah.
Excellent.
Yeah.
Akil would like to know, how do you declare view models in TypeScript?
Well, it's not really a TypeScript question. It's more a question of which framework are you using in your JavaScript backend or front end, depending on where your view models are running. Typically the way, but if you were doing it in TypeScript, and I've seen people doing it with Backbone, for example, is like you would either use classes or interface declarations in TypeScript. Typically you can use interfaces and then just wrap them around like anonymous or anonymously typed objects. You could just basically assign them to an interface type thing, and now you have statement completion on that. So yeah.
Excellent. Thanks for all the questions, everyone. This is great. So Breno wants to know, would it be possible for the TypeScript compiler to block global variables? So window, document, if not explicitly requested.
Sure, it's possible to block. In fact, it's possible for you to a large extent to block it. I mean, you could remove. So the file that declares all those global variables, like document and window and so forth, is lib.d.ts, which is the file that contains the JavaScript runtime library and the DOM typings.
Okay.
And you can edit that file. That's just another file. You could go in, edit it, and like comment out all those global variables if you don't want people to access them. You could also envision us like forbidding you from creating global variables, although it's hard to do that and sort of meaningfully claim to be a superset of JavaScript, right? So,
sure.
Yeah.
Well, hey, Anders, it's wonderful to talk to you again.
Always
I wish
a pleasure.
we had more time.
Always a pleasure.
Man.
Yeah, no.
Thanks for joining us. I know we had a great conversation with TypeScript with Anders. That was live, and we had to shut it down a little early because there was this other thing that was live that was coming in. We noticed there were a lot of questions about Roslyn and C#. So now Anders has kindly agreed to hang out for a little while longer, and we'll get to some of your questions. So right off the bat, Anders, Max wants to know, is there going to be a new version of C# in the next version of Visual Studio?
Right. So VS 2013 is a very short cycle release. I mean, it's basically just a year later. We've switched to a much faster cadence. So that release will be the same C#, and we're targeting for Roslyn the next one after. Okay. Is basic. But we're going to start previewing Roslyn, as soon as we can.
Okay.
Because we are actually now at a point where the Roslyn compilers are done. Nice. And we're compiling pretty much all the managed code we can find in-house and externally. We've literally scraped CodePlex, GitHub for code, and we keep finding little issues, but we're reaching a very high level of stability at this point, and we're working on the language services, and we're finally getting there.
Excellent.
Yeah.
And so Al, nice to see you again. As Andrews just said, it's not going to ship in VS 2013 Roslyn.
Right.
You'll probably see a preview at some point in time before 2015.
Absolutely.
That's a fair enough.
Oh, yeah, no, sooner than that.
Awesome.
Yeah.
So Shaggy wants to know, any news update for Roslyn? Is there a new CTP soon?
We've talked about CTPs, and I think that the CTPs, the way we're thinking about it right now is we need to get VS 2013 out. We have done prep work in VS 2013 such that we can just drop in Roslyn compilers as V6s.
Nice.
Or VSIX extensions, and then you can just enable, disable, to test them.
Great.
And that's based, so all of that infrastructure is done. So once we get VS 2013 out, we'll be able to start previewing Roslyn. Yeah.
And so to be clear, the goal is that Roslyn will be the compiler for C#.
Yes.
At some point.
Well, and VB.
And VB, of course.
And the new language services, the IDE, yes, is all written on top of Roslyn then.
Awesome.
So there's a huge amount of work there. And the thing that it's taken longer than we thought, I will readily admit. The thing that you can't ignore is that there are millions and millions and millions, and I venture to say probably even billions of lines of C# code out there, and we got to compile all of them correctly. We can't just say, oh, well, sorry, that doesn't work anymore. This is about attaining the elusive 100% backwards compatibility, which is hard because there are actually things in the old compilers where you go, well, but that's clearly wrong. Because we do the right thing for this, but then in this particular case we do the wrong thing. Now, should we keep the bug? Because when we fix the bug, then that breaks. And, well, yeah, so is it a new warning? It's a puzzle, right?
Wow.
And then so we're spending a lot of time on getting that just right, but it takes time.
So now one of the questions, this is related, Nick is asking this, because your old compiler was written in native code, right? In C++, or C and C++.
Right, C minus.
C minus, exactly. Maybe you had some classes. So are you noticing an increase in compile time since you're using, so what is the performance characteristics of Roslyn?
Sure.
Is what he really wants to know.
Right. So right from the get-go of the Roslyn project, we set some hard goals that, at no point during development did we want to be more than 2x of the old compiler. And that was just during development. And we wanted to at least reach the same speeds as the native compiler in the final release. Now, the way we get there, though, is different. One of the things that's interesting about the Roslyn compiler is that it's a much more modern code base, and it's written using more modern, more functional algorithms. And that means a lot of the data structures in the compiler are immutable, like the entire AST, abstract syntax trees that you can work on. The entire API for that is basically one big immutable data structure. Wow. Now what immutability gives you is it gives you sharing for free. And that means this compiler, unlike the old compiler, works beautifully on multi-core systems. And if you have a 4-core machine, we can farm out a lot of the compilation work to run on separate cores. Not only can we, of course, if you have 4 completely separate compilations, we can spin up 4 separate processes. Yeah, that's a given. But even for a single compilation of a very large project, we can internally parallelize IL generation, for example, because each method is individually independent of each other, and so we can generate IL. The emit phase can go 3 to 4 times faster because of the ability to take advantage of all the latent parallelism. So in the aggregate, when you look at how does this new compiler perform compared to the old compiler, it's actually, in many cases, beating the old compiler, particularly for large projects.
Cool. Because of the ability
It scales a lot better.
Excellent.
And scalability was all, I mean, we have like, I mean, you wouldn't believe the size of some of these projects that people have built in C#. They're enormous.
Sure.
And we need to we need to be able to open them all up and work. And so typing responsiveness in huge projects is vastly better with Roslyn. So there are a lot of advantages that we're getting out of this.
Awesome. Ramoko wants to know what. Well, this is an interesting one because Anders, look, let's get this on the table right now. You still work on C#?
Oh, absolutely.
Okay.
I mean,
is C# going to evolve?
C# is my day job. You know, now I've been
There.
pitching in on TypeScript. You know, and I have at times spent more than half of my time on TypeScript in the last year or so. You know, as the Roslyn team has been doing all of this hard work to finalize these compilers. It's actually been a very good opportunity, you know, because there was some downtime there because that just took longer than we thought. And that allowed me to work on language design and TypeScript. And heck, you know, at heart, I like language design. And so if an opportunity like that presents itself, you know, I'm not just going to sit and let it go by. But yeah, no, C# is absolutely still my day job. Yeah.
Awesome. So one of the things I think is interesting, because you've been focusing a lot of your time, and necessarily so, on TypeScript, have you learned anything from that work that you might consider applying to a really statically typed language?
That's a good question. I think I have certainly, I'm coming away from it with a new appreciation for the value of sort of dynamism or dynamic typing being completely effortless, right? I mean, we have support for dynamic in C#, but sometimes it's not quite as smooth as I would like it to be, and we've definitely got some ideas there about, you know, say, for example, making it easier to just suck up a JSON document and dynamically dot into it in .NET. Wouldn't that be nice, you know? And that's actually not as easy as it should be today, right? And, and so there are things like that we're looking at. I think from the language design, I think it goes both ways. We actually, you know, we've been thinking about ways of making C# classes more succinct, and you know, by looking at some of the things you can do in F#, where you can put parameters on classes and then capture them in methods inside the class, and you can get down to a very succinct style of writing your code. And we used some of that early on for a model of classes that we implemented in TypeScript, but then the ECMAScript 6 committee went in a different direction, and so we aligned with that instead. But that was actually interesting to be able to apply some work that hadn't even seen the light in C# yet in TypeScript, you know, and harden it further there. And so we may revisit that once we get done with Roslyn. And we actually have now, in earnest, accelerated the C# language design meetings again, so we're doing them on a regular cadence now, looking at C# 6.0 and a bunch of new features there, and also just looking at all of the issues that people have logged over time, you know, against C#, and then like, is it time to like finally fix this issue or this issue or this issue? We have sort of a hit list of just do it features that we ought to just do.
Absolutely.
Because now with or just do in the Roslyn code base, because now that we have a code base that is so much easier to do these things in than it was. You know, there was a big cost in the old code base to doing stuff, and that cost has gone down dramatically, so we should be able to move a lot faster now.
Right on. And of course, since C# was released, the world has changed in the sense that, you know, developers are writing mobile applications, right? They're writing these, they're targeting different devices and stuff like that.
Yeah.
So the programmer has evolved and changed. How is that going to impact a language with such a rich history as C#?
Well, I think, you know, I mean, there are many ways it impacts, right? I mean, there's from a language perspective, like I just talked about, like dynamic data is getting more and more important, you know, and the ability to talk to like web services and so forth in a completely frictionless manner is very important. I think on a lot of mobile devices and small form factors, you know, battery consumption is important, so native code is getting more important, you know. It's like it costs battery power to JIT an app.
Yes.
You know, and so maybe if we didn't do that, we could start up faster and use less power, right? And
awesome.
so you know, like, so somehow delivering native code to devices is getting more important. Many different things, and I think it's also great to see, you know, like third parties out there like Xamarin,
yes.
you know, and their usage of C# on other mobile platforms and the ease with which, you know, you can build like a common compute core in your app and then just shape the API, the UI for the different mobile devices.
Absolutely.
I'm a great fan of their work. So yeah,
awesome.
Yeah.
Right on.
Yeah.
So we talked about what are the plans for start. Well, I mean, basically, you can't talk about the specific plans. You sort of just elaborated a lot of some interesting ideas. Do Roslyn come with a Go Live license? So when you release CTP, are you going to be like typical Visual Studio beta Go Live stuff?
I'm not sure.
Okay.
We likely will have a Go Live license. We usually do, but we have not worked out those details as of yet. Yeah.
So of course, Enough Labs wants to know: is the effort on TypeScript slowing down efforts on C#?
Actually, strangely, no. Because, like I said, you know, getting to completion on the Roslyn compilers has taken longer than we thought. Plus, in their defense, you know, we've decided basically to go to a more rapid release cadence with Visual Studio, and so you're seeing more releases than we had originally planned for.
Sure.
You know, the time horizon for the Roslyn release hasn't actually changed. It's just we've slotted in more releases of VS.
Okay.
But the TypeScript work, it hasn't really, because, you know, there's still a Roslyn team that goes to work every day and works on the Roslyn compiler. Now I float above, you know, and I've helped the TypeScript team, but honestly, a lot of the design work that we're doing there is we're building a healthy muscle of language design at Microsoft, not just in C# or VB, or F#, but also in the JavaScript space, and that's a good thing for everyone, you know, because these communities bleed over each other, and you learn something new every time you do something, and then you bring it back to the table on the other side, right?
Absolutely.
So, yeah.
I mean, a canonical example in the C++ world is they're in love with async await.
Yeah.
And wouldn't it
I'm
be
in
nice?
love with it.
I'm sure it's a wonderful thing.
It's an awesome thing.
So
yeah,
I really hope something interesting will happen in that space. And there also might be things in C++ you look at and go like, you know, polymorphic lambdas or something. Maybe that would be interesting.
Who knows?
In C#.
Yeah.
But Pontus wants to know, man, have you always looked like a freaking rock star, Anders?
I don't look like a great. Well, I guess a lot of rock stars have been here today. Yeah.
On that note, rock and roll.
All right.
Thank you
My
for
pleasure.
coming
All right.
and doing the extended period.
You bet. You bet.
Thanks for the wonderful questions, people. Cheers.